Hello students, welcome to the lecture on engineering mechanics. Today I will cover introduction and basic concepts of this course. So let us start the lecture. So let us see the definition of engineering mechanics. In the zero lecture as well, we have discussed that it is a branch of physical science which deals with the motion of bodies under the action of forces. So basically, we study that what will be the effect of forces on the state of motion of the body. So by state of motion, we mean we want to know that what will be the change in the state of motion. If the body is at rest, then if I apply certain forces on the body, what effect those forces will produce on the state of body, which is rest we have considered. Now another state of motion of body can be motion, that body is in motion and we are applying certain forces on the body, and now we want to know that what changes those forces can make on the state of motion of the body. So we are basically concerned with the physical quantities of the body. Physical quantity means like mass, time, velocity, acceleration, displacement of the body. So in other words, we can say it determines the state of motion of bodies under the effect of forces. So as I said, there can be two state of motion of the body. It can be in rest, we can say the body is in equilibrium, or we can say the body is in motion, that is not in equilibrium. So in this subject, we analyze that if we apply some forces on a body, what effect those forces have on the state of motion of the body. Now, basically, we deal with the physical quantities, that is mass, time, displacement, velocity, acceleration, and so on. This course acts as a foundation for many engineering problems where you have to design certain machines or you have to observe the behavior of certain machines. Then you need the knowledge of this particular course that we will see in the coming slides. So in engineering, there are many problems that are related to the determination of the state of motion of bodies under the action of a set of forces. Let us take few examples. Like if we want to find that is a dam stable or will it tilt due to the water pressure acting on it. Another example can be that what is the power of a motor that should be used for raising a particular quantity of water through height in a certain amount of time. So for solving such problems, an engineer needs to be well versed with the application of the principles of mechanics. Now we will see the branches of mechanics. Now, depending upon the problems we deal in this particular course, we have divided mechanics into two main parts. The first part is called as dynamics, and it is further divided into two categories, kinematics, kinetics. Second part of this course is named as statics. Now we'll see the definition of these in the coming slides. So let us start with the dynamics first. It deals with the motion of bodies under the effect of forces. So basically, under this category, we deal with the problems where the body is in motion and the body is under the effect of certain forces. Means body is not static, it is moving. So such problems are covered under this category named as dynamics. So as we said, it is divided into two categories, kinematics and kinetics. So let us first see what is kinematics. So let us read the definition. It deals with the problems related to the determination of the nature of motion of bodies, that is their displacement, velocity and acceleration, without any regard to the forces acting on them or the masses involved. So let us understand this through an example. Suppose we have a body and it is moving with some velocity, and we want to know that after certain time t, what is the displacement of that particular body. So such problems will be covered under kinematics because we are curious to find the displacement. We are not focusing on the force acting on the body. Means we are not focusing on the forces acting on the body, we are just focused on the displacement, velocity and acceleration of the body at any time t. So such kind of problems are categorized as kinematics. Next category of dynamics is kinetics. So let us read the statement first. It deals with the problems which require the determination of effect of forces on the motion of a body, or conversely the forces causing a certain motion. So basically in this case we are concerned about the forces now. Let us understand this through an example. Suppose we have a body and it is resting on a surface, and we want to find out that what amount of force I should apply so that the body should attain an acceleration of 8 meter per second square. So means we are concerned about what kind or what amount of force I should apply so that body should attain this acceleration. So we are concerned about the force. So such problems are covered under category kinetics. And the second main branch of this particular course is known as statics. So what is statics? It deals with the problems concerning the equilibrium of bodies under the effect of forces. So in this case, in the problems, body is not moving, body is at the state of rest. So let us understand this through this example. Suppose we have a body and it is tied to these 2 points with the help of cables. Now the whole system is not moving, it is in equilibrium. And in this system, we just want to find that how much force we need, let us say in these two cables, in order to maintain the equilibrium of this particular body. So the body is not moving in the problem, it is at rest. So such problems are covered under statics. Now we will cover some basic terms. I hope you already know these terms, but still I feel that I should discuss these terms once again with you so that we should be ready for the coming topics. So the first one is space. What is space? We all know it is a region which extends in all directions and contains everything in it. The next is matter. Any substance which occupies a space is called matter. Next is body. Any matter that is bounded by a closed surface is called a body. Next term is force. So what is force? Force is that which changes or tends to change the state of motion of a body. That means suppose we have a body and we are applying force on the body, and suppose the body initially was at rest, and when we apply force on the body, so there can be two effects. Either it will change the state of motion of the body, or it will tend to change the state of motion of the body. It is induced by the action of one body on another, or of a field, that is magnetic field, on a body. The change in motion due to a force takes place in the direction of the force. This is a very important point to understand, and we all know that this is related to Newton's second law also. So when we apply some force on a particular body, so the motion of body takes place in the direction of the force applied. We will cover a detailed chapter on force in the coming lectures. Now let us talk about equilibrium. So what is equilibrium? A body acted upon by a system of forces is said to be in equilibrium if it either remains in a state of rest or continues to move in a straight line with uniform velocity. So in this case, basically we cover two things, that if the body is at rest or if it is moving in a straight line with uniform velocity, means the acceleration is zero. So in these two cases we can say there is an equilibrium. So we will learn in detail about this particular topic, equilibrium, in the coming lectures. Next is inertia. So what is inertia? The resistance offered by a matter to any change of its state of motion is called inertia. Suppose we have a body and we want to apply some force on the body in order to move it in some direction. Suppose initially the body does not move. It means what? Why it is not moving? Because it has some initial inertia which is overcoming the force applied by us. Next is particle. A particle occupies no space, that is, it has no size but has a definite mass concentrated at a point. In the solution of engineering problems, many a time when the size of a body is very small as compared to the path it travels, the body is assumed as a particle. So basically when we solve some problems in this course, let us take one example. Suppose we want to find out that what distance is covered by an aeroplane in a particular time. Fine. So in that case you will find that aeroplane is very small as compared to the distance traveled by that aeroplane. So we consider aeroplane as a particle in that case. So it helps us to solve the problem that you will come to know where you will actually solve some problems in this course. Now next is the rigid body. Let us read the definition first. A rigid body is that which does not undergo deformation on the application of forces. Now it seems a bit contradictory over here, but let us read the next line. In other words, the relative position between its parts does not change. Now see what he's writing over here. It is impossible to find a body which does not deform under the effect of forces. However, if the deformations are relatively small, the body is considered as rigid. So one thing to understand over here, whenever we apply some force on a particular body, so there is a tendency that body will get deformed because nothing is there in this uniform which does not undergo deformation. There will be some deformation because of force acting on the body. But in this course, when we want to solve some problems, in order to make the solutions easy, we consider that our body is a rigid body. That means whatever force I apply on the body, that will not deform the body, that will totally result in the change of state of motion of the body. So we only consider rigid bodies to solve the problems under this course. Fine, this you should keep in your mind that whenever we will solve some problem, whenever I say a body, then you must understand that we are talking about rigid body which does not undergo deformation on the application of forces. Now next is quantities. A physical quantity is one which can be measured. All physical quantities can be classified as scalar and vector quantities. Of course, let me take one example over here. Suppose there is some body and we can measure its mass. So that is a physical quantity because we can measure that. Okay, so let us first see scalar quantity. Scalar quantities are those which can be completely defined by their magnitude or numerical value only. Means there is no need of specifying their direction. Only by magnitude we can completely define those quantities. Let us take one example. Take the example of a speed of a vehicle. So when we say 40 km per hour, then we are telling about the magnitude. So we are not telling about the direction of the speed. Fine. So only magnitude is sufficient to tell about the speed of the vehicle. So such quantities are called as scalar quantities where only magnitude is sufficient. There is no need to provide the direction. Let us take another example. Suppose we want to specify the temperature of a body, and when we say that temperature of a body is 50 degrees Celsius, we are giving only a numerical value 50. We are not giving its direction. We are not saying that in this direction the temperature is 50 degrees Celsius. No, we are just saying that temperature is 50 degrees Celsius. So it means there is no need of direction, there is only need of numerical value, that is the magnitude. So such quantities are called as scalar quantities. Now we will see vector quantities. Let us read the definition. Vectors are the quantities which require not only magnitude but also direction and sense for completely defining them. So let us take one example. Suppose there is a block and I want to displace this block in some direction. Let us say at 45 degrees. Fine. Then I have to show vector as well in order to convey its displacement. I will say that it has moved by 10 meters, but now I have to tell that in which direction it is moved if I want to talk about its displacement. So in vector quantities, along with the magnitudes, we have to talk about the direction as well. The length of the line indicates to a certain chosen scale the magnitude of vector quantity, and an arrowhead marked on the line shows the sense of the vector. So if I have to draw a vector, I will choose its length to some scale. Suppose the magnitude of this vector is, let us say, 10 meters. So I assume that if I will draw a line of 5 centimeter, that is representing 10 meters. Then I have to show the direction as well, then that in which direction actually that particular vector is acting. Now, next topic is reference frame of axis. We know that space is a region extending in all directions. Position of a body in space can be defined only by referring measurements to a fixed frame of axis. The measurements may be linear, angular, or both. We also know that there is nothing stationary in the universe, and therefore it is not possible to have a fixed frame of reference. Most of the problems in engineering deal with the motion of bodies on or near the Earth's surface. Therefore, for such problems, the reference frame of axis is taken on the Earth's surface, which is assumed fixed for all practical purposes. That is very important. Reference frame of axis are very important. Suppose we want to solve some problems and we want to specify the position of a particle. Then we have to tell the position of a particle with respect to some reference. We will say that the particle is at a distance of, let us say, 10 meters from a particular point. Means in order to solve the problems, we always have to choose the reference frame of axis. So that we will see in the next slide. So there are two reference frames. We call first reference frame as rectangular coordinate system. So what we do in this system, suppose we have a particle P, and let us say this is the particle, and we want to convey its position. So if we are dealing with rectangular coordinate system, we will make use of two axes, x-axis and y-axis, and we will fix the origin of those two axes. Now with respect to that origin, we can define the position of the particle. We can say that it is x units from y-axis and it is y units from x-axis. So we can locate its coordinates as x, y. So these two coordinates will help us to define the position of the particle with respect to this fixed origin. Now the next method is called as polar coordinates system. So let us see what we do in this system in order to define the position of the particle. Suppose this is the position of the particle P. So in this system what we do, we choose one origin which is fixed. Suppose this is origin and it is fixed. And we want to define the position of particle P with respect to this fixed origin O. So for that what we will do, we will connect the particle with this origin with the help of a line. We call this as a radial line. And then from origin, we will draw a horizontal line OX. We call this as a baseline. Now in order to define the position of particle with respect to this origin, we will say that it is r units from the origin, which is a radial line, and that radial line has an angle of theta with the baseline. You can see over here beside P we are writing r comma theta. So in polar coordinate system, the position of the particle P is defined r comma theta, where r is the radial distance of the particle P from the origin O, and theta is the angle made by radial line OP with the baseline OX. So we use these two coordinate systems whenever we solve some problems in this particular course. Next we will talk about principles of mechanics. The science of mechanics is based on the following principles, which are empirical, that is, they are established through experimentation and observation and have no analytical proof. So we will see certain principles over here now which are important from mechanics point of view. So the first one is Newton's first law of motion. So we all know this law. Let us read the statement once again. Any particle will continue to move in a straight line with uniform velocity or remain in a state of rest if there is no unbalanced force acting on it. So it is a very simple law. It states that if we have a body and if there is no unbalanced force acting on that body, then the state of the body will be maintained. That if originally the body was at rest, it will still remain at rest because there is no unbalanced force acting on it. Similarly, if initially the body was moving with some velocity, let us say uniform velocity with zero acceleration, and no unbalanced forces are acting on it, then it will keep on moving. Fine. So over here it is explained through this figure also, that suppose we have a body and two forces are acting on this body and both forces have equal magnitude and they are acting on the same line of action. So net effect because of these two forces is zero. So body will remain at rest throughout the process. So we will say that it will remain at rest because there is no unbalanced force acting on it. Newton's second law of motion. Let us read the statement. The rate of change of momentum of a particle is equal to the unbalanced force acting on it and takes place in the direction of unbalanced force. Now let us understand this law. It says that if we have a body and if we apply some force on that body, and then there will be a change in the momentum of that body, and that change will happen in the direction of the application of the force, and the rate of change of momentum will be equal to the unbalanced force. So from this law we get one equation. So we say that force applied on the body will be equal to rate of change of the momentum of the body, and this rate of change of momentum will take place in the direction of the force applied. So when we will solve this further, as we know that mass is constant, so when you take the derivative of velocity, it will become acceleration. So from Newton's second law of motion, we get this equation F is equal to ma. We will use this equation in few topics of this course, and there we will learn its application. Now next is Newton's third law of motion. This we all know. To every action, there is an equal and opposite reaction. So over here you can see one example is shown. This is body A, this is body B. So if we rest this body A on the top of body B, then this particular system will be in equilibrium only when the weight of body A is balanced by the reaction provided by body B. You can see over here, the weight of body A is acting in downward direction and this body B is giving it equal and opposite reaction R. So this particular system will be in equilibrium. So to every action there is an equal and opposite reaction. Next is principle of work and energy. Work done by a force or set of forces on a particle in moving it through a distance is equal to the change in kinetic energy of the particle. Suppose we have a body and let us say there is some initial kinetic energy of the body and let us say that is T1. And suppose we have applied some forces on the body and because of those forces body has moved by some distance. It means those forces have done some work on the body. Now let us say the kinetic energy of the body is changed to a new value, that is T2. So this law says that work done by the forces will be equal to the change in kinetic energy of the body. That will be equal to T2 minus T1. So this particular law we will cover in detail in the coming lectures. Next is principle of conservation of energy. The principle of conservation of energy states that in any reaction within a system or in a process, no energy is either created or destroyed. It only changes from one body to another or from one form to another. Now next we will talk about parallelogram law. So let us see what is a parallelogram law through an example. Suppose we have a body and on that body two forces are acting, and let us say these two forces are acting at a common point, so we can call these forces as concurrent forces that we will study in detail in the coming lectures. Now let us say this is force F1 and this is force F2, and we want to find out their resultant force. Fine. So how we can get the resultant force? That we can get through parallelogram law. So what we say in parallelogram law, that if we have two forces, let us say these are concurrent forces, then we can make those forces as two sides of a parallelogram, and we can complete the parallelogram by using these two forces only, and then the longer diagonal of the parallelogram will be the resultant of these two forces. So this law we will use when we will solve some problems in unit 1. Next is law of transmissibility. This is a very important law. We will use this law in the problems. So let us read the statement. The effect of a force on the condition of equilibrium or the state of motion of a body remains unchanged if its point of application, say A, on the rigid body is transmitted to another point, say B, on the same body along its line of action. Let us understand this through an example. Suppose we have a body, and on that body we have applied a force of magnitude F at point of application A on the body. Now suppose this particular force has resulted in the acceleration of the body as 10 meter per second square. Now what this law says, let us see that. Now let me first draw the line of action of this force. So if I extend this force, so I will get its line of action. So if I consider a new point of application on this line of action and on the body. So new point of application of the force is on the body and on the line of action of the force. Now if I shift this force from first point of application to new point of application, which is on the body and on the line of action of the force, then what will happen? Net effect will remain same. That means still this body will move with an acceleration of 10 meter per second square. So this you should keep in your mind. This law is very helpful when we solve some problems related to force system. That's all regarding the introductory part of the course and the basic concepts. So now I will take your doubts. Thank you very much.